As chemists, we often try to mimic what nature does because nature has developed very intricate pathways to make very complex molecules, sometimes to make very simple molecules, but very efficiently. Probably upwards of 50% of all drugs on the market are either coming from natural sources in some way or derived from that. Penicillin, right, comes from a natural source. Morphine. So it's a really wonderful place to kind of get new medicines. My name's Stephenson. I'm a professor of chemistry and biochemistry and molecular biology here at the University of British Columbia and the Canada Excellence Research Chair in Innovative Synthetic Methods for Translational Chemistry. We use light and electricity to promote chemical reactions in my laboratory. It's something that nature does all the time, right? So plants are constantly using energy from light to convert carbon dioxide to fuel for themselves and for building blocks, and then give off the air that we breathe. So sometimes we want to make less complicated versions of those molecules, right? That then can mimic the same function, but maybe are easier to make. They don't cost as much to make. So ideally in a chemical reaction, one compound or one thing gets converted to simply one other thing. And by using light, we can actually impart quite a lot of selectivity in the chemical reaction. And the flavor of photochemistry that we do uses visible light. So the first reactions we were doing, we were using a simple light bulb that you buy at Home Depot. And then the pharmaceutical industry said, wow, I could see how we could use that, and that would be really enabling. And I would say the chemistry really just took off. What UBC wanted when they brought us here was to develop this world-class place where people want to come do chemistry with the eye towards translating it to real problems in human health.